Let's see if this is any better. Reset our timer. Yep. Computer's under high load. Honestly. I'll change the graphics to go through the NVIDIA card. So hopefully this should stream a little bit better. So the voice is good. Obviously watching a video within a video is not going to be helpful. See what happens when I go here. Sure it's still recording. Seems to be alright. Okay, let's give it a go. Let's see what we win. Okay, so today, what should I do? Do a lot of solution architecture and designs with dev teams. And one of the things I try and do is keep us using common patterns. And what I like to do is I just like to keep dipping my toes into the architecture patterns and seeing what's popping up, if there's anything new. For instance, cell-based architecture. There's a thing from AWS about what they're calling cell-based architecture. Had a little bit of a look at it, and cell-based architecture appears to be like vertical stripes. Vertical stripe architecture. Look at YouTube. Vertical stripe, I think. Good spell. Yeah, a vertical slice architecture where you have like a presentation layer, an application layer, domain, infrastructure layer, and you put all the parts in. Great video, by the way, this, well worth a watch. And you basically make sure that you reference only the things within. So, presentation layer references application, and then the domain layer, and then the domain layer can only access the application layer, and so on, so that you get this clean layered approach. If you look at preferences and projects, and you would look at what references you've got, you would only see that the domain couldn't access the presentation layer. The presentation layer couldn't access the domain layer directly. So cell-based architecture appears to be that for the cloud. Going off topic, but hey, my stream. What I wanted to do is have a look to see if there was pipes, and there is. We've got pipes and filter patterns. Now, in my opinion, pipes and filters, if we just have a quick look at it, you can see that you've got data coming in from two sources, going into different tasks and being worked on. One of the cool things to know is that in here, we've got task B, and we've also got task B here. So we can kind of like duplicate things and reuse components. So, if you were stripping all strings out, well, that might be useful. Stripping all spaces out, or bleeding characters, or escape sequences. I reckon that could be really useful to reuse and keep on pushing through. So data goes in, gets transformed, gets transformed, gets transformed until eventually all the data comes from two different data sources, like two different files, API streams, whatever. And that data then goes into this business logic. So if we have a look at this, so pipes and filter patterns decompose a task that performs complex processing into a series of separate elements that can be reused. Yeah, absolutely. You know, being able to grab and work on just the right thing at the right time. Some people negatively might call them things like nano services, but actually they're something that does something that the business needs and does it really well and can be swapped out, you know. So doing so can improve performance, scalability, and reusability by allowing task elements that perform the processing to be deployed and scaled independently. Yeah, so I kind of take this pattern and I go like a little bit too far in some cases with this, with a distributed system. So imagine each one of these being a separate system running in Kubernetes, let's say. And each one of these is a little job that's running, waiting to get input and waiting to stream that out. If you use some kind of message bus, then you can actually push data in, and then its responsibility can be to send it out to the next person in the chain. So the following diagram illustrates one of the problems with processing data using a monolithic approach: the inability to reuse code across multiple pipes. Um, you know what? There's nothing wrong with a monolithic approach. There's a couple of things there. Um, one of the following diagram illustrates one of the problems with processing data using a monolithic approach: the inability to reuse code across multiple pipes. Well, that's simply not true. If that was a monolith and that was a monolith, then yeah, of course, you would have to extract that code and put it into something, or make a package and import that package into, use that package in both, which is fine. You know, packages or NuGets or whatever you're using, and that would then be two monolithic applications. But if you just had one great big monolithic application, well, you can reuse that bloody function anywhere. That's kind of the problem with monolithic applications, is that developers have access to everything all the time, constantly. You know, and that's why you need to not you should implement some kind of pattern like this to kind of give it some structure. Otherwise, what you've got is an application where everything is accessible at all places. I mean, I've worked on stuff where from within a note domain class, you were able to get access to bank account details. So a developer would be able to follow the chain from notes to case to application, back down into accounts, back down into system, back down into bank account, because everything was available all the time in this great big monolithic application. And there wasn't any bounded context, there wasn't any layers to prevent a developer from doing that. So that's a little bit misleading, but I think let it cook and let's see what happens. In this example, an application receives and processes data from two data sources. An application. Okay. A separate module processes the data from each source by performing a series of tasks to transform the data before passing the results to the business logic of the application. Okay, so there's monolithic module doing shit, moving from one to one and transforming the data. So some of the tasks that the monolithic module performs are functionally similar, but the code has to be repeated in both modules and is likely to be tightly coupled within its module. In addition to the inability to reuse logic, the approach introduces risk when requirements change. You must remember to update the code in both places. It's not really a great article so far, because it's basically just whipping microservices without actually telling us anything about pipes. And I'm 10 minutes in. So you must remember to update the code. Yeah, of course you do. But if you have a module or a shared reference, a shared link, a NuGet package, then you update it and you deploy it into both. Problem solved. So the solution. Break down the processing required for each stream into a set of separate components, filters, each performing a single task. The filters are composed into pipelines by connecting the filters with the pipes. Filters are composed into pipelines by connecting the filters with the pipes. Right, that's another thing I'll talk about in a sec after it's cooked. Filters receive messages from the inbound pipe and publish messages to a different outbound pipe. Pipes don't perform routing of any other logic. They only connect filters, passing the output message from one filter as the input to the next. Okay, right. One thing I did was when I was looking into stuff like this, where am I? What directory am I in? So yeah, I should be able to come here. What have we got? I can't remember where it is. Pipes. Nope. What was it like? Trying to think of what it was that I was doing, which was similar to this. I think there's a. Trying to think what it was called. Mediator. That's it. It's just that. There we go. Look at that boy. Look at him. He's super fast. Look at him go. So can I find that? What was it called? Media TR. So media TR. Media. Nope. Go down one. Let's see if it's in here. Let it cook, let it cook, let it cook. Come on. A lot of files in here. There's a lot of files in here. Need to start cleaning stuff up, I think. There we go. So it's part of the training platform. So CD training, GoLang, go-mediatr. Let's have a look. Hmm, shortcut's not set up on this machine. Gizzard. Okay, pokey. So what have we got? This is what I wanted to show. There's this, as we're talking about pipes. You have a look at this. It's saying each thing can call a separate component. Each filter is a single task. The filters are composed into pipes by connecting a filter with a pipe. So you connect one thing and call another thing, pass that data across. Filters receive messages from an outbound pipe and push the message to a different outbound pipe. So this is very similar, I think, to channels, because you can push something into a channel, stream data in, it can mess with it, and then it can then send that to another channel. Now, the order of what it sends it to is the problem, is the thing, is that task A says it's got to send stuff to task B. Task B says it has to send things to task C. But what happens when the business changes that process? Let's say they jumble it up completely, that'd be a pain. But even if they just say, I want task C to be first, task D to be second, you've got to go into each one of these applications and change the pipeline. Say that, right, task A now has got to send to task D, task E sends to C, and task C sends to B. But moving stuff around like you would do in like a linked list or something. Doing that in these filters is problematic, and I don't like that. So pipes don't perform routing or any other logic. They only connect filters passing the outbound message from one filter as an input to the next. Yeah, streaming data across. Filters act independently and are unaware of each other. So of course there's got to be some kind of contract, right? There's got to be some kind of interface that says how this data looks. I said there has to be. There doesn't have to be. You could pass a string and then an int and then convert it and do whatever you want, and it could just be interface as just an any. They're only aware of their input and output schemas. Yeah. As such, the filters can be arranged in any order so long as the input schema for any filter matches the output schema of the previous. Yeah. Yeah, and you output a person object, you're not expected for that to then send an address object to the next thing. You're expecting that to mess with the person, maybe validate it, maybe check it against a registry, check it for, approved persons or against the sanctions list or whatever, and then move that on to the next filter. So as such, filters can be arranged in any order. Using a standardized schema for all the filters enhances the ability to reorder filters. Great. That's exactly what I was talking about. And they're saying that within the spec. So the loose coupling of filters makes it easy to create a new pipelines composed of existing filters. Lego. Get a bit of that, get a bit of that, get a bit of that. If you've got one that's going to do an IDMV check or one that's going to go and do a postcode address lookup, you could just pull them in. Beautiful. Developers can work on these individual little pipes, and some orchestrators somewhere can just start gluing them all together. Love it. Reorder filters when necessary, turn them off and on, maybe. Running filters on different hardware where required, of course. Running filters in parallel. Yeah. Yeah, you know, if you're sending an email and you're also adding a note and they're independent, you know, it's just some note and then some email. If that's part of that unit of work, then you could do that unit of work in parallel, just by using multiple. So you could have task A then does B and C simultaneously, and then goes to D. Waits for the output, maybe waits for them both to complete, and then sends the data and messes with it. Just like, oh, just like that. Time to take The time it takes to process a single request depends on the speed of the slowest filter in the pipeline. Isn't that always the case, you know? Slowest person, generally me, lets the team down. One or more filters could be bottlenecks, especially if a high number of requests appear in a stream for a particular data source. Look, I'm going to be slow with MPRs, right? I am going to be methodical. I'm going to go through them. I'm just going to look at them and approve them. If that bothers you, then, you know, you got an issue. The ability to run parallel instances of slow filters enables the system to spread the load and improve throughput. Like, you don't run stuff in parallel for speed. What? You run stuff in parallel because you can, because they're independent. Like, for instance, it makes no sense, especially in languages like Go or C Sharp, where it's so easy to do things in parallel, that if you're going to do that and that and that, what's the point in waiting for that one to finish and that one to finish and then that one to finish before you then move on to task B? There's no point. As long as this doesn't require data from here, there's no dependency on these two things, then you run in parallel. But I would really deter people from thinking that because I can run things in parallel, I'm going to make it quicker. If that takes 1 millisecond and that takes 5 seconds, then you're going to have to wait 5 seconds. If you did them not in parallel, synchronously, yeah, then it's going to take 5 seconds and 2 milliseconds. So what? You know, it's not what you're doing. It's the fact that you can, especially with Go, you know, Go routine off your pop. It's just beautiful. The ability to run filters on different computing instances enables them to be scaled independently and take advantage of elasticity that many cloud environments provide. Yeah. Yeah, absolutely. If you look at that, then the ability to run filters on that, you know, and run this high demanding task is great. I see my chat window, by the way, so if anyone's talking to me, I'm really, really sorry. Um, Let me have a look. Just bear with me 1 sec. Da-da-da-da-da. Yeah, that'll be fine. No, I'm a lonely, lonely loner. Oh dear. Let's see if I can move that over here. Pop this out. Right, so the ability to run this on bigger hardware is just awesome. Now, if the input and outputs of the filters are structured as a stream, you can perform the processing for each filter in parallel. First filter in the pipeline can start its work and output its results, which passed directly into the next filter and in sequence before the first filter completes its work. Yeah. Using the pipes and filter pattern together with the compensating transaction pattern is an alternative approach to implementing distributed transactions. Right, that's a whole different kettle of fish. That's a whole new stream. You can break a distributed transaction into separate compensatable tasks, each of which can be implemented via a filter that also implements a compensating transaction pattern. You can implement the filters in a pipe as a separate hosted task that run closer to the data that they maintain. Right. So one of the problems with this is that each individual pod or pipe, filter, does a job. They call it tasks here, but they're filters. Now, if this is buying a product, then you can't just have one of them fail. You know, if that's processing an order, and this is just stock in warehouses, distribution, invoicing, accounts, and emails, then you're gonna have a problem with this, because you just sent a shipping order or a stock level. You've reduced your stock intake, distribution, and now you're going to send it. Accounts are going to start processing the payments. An email's going to go out to say you've got it, and payment didn't go through. So it's difficult, right? Let's say this is payment. This is the payment system. These are doing the order, searching for the orders, basket, and other things, and that's maybe sending an email to say, you know, your order's being processed. If this fails, then you have to think about how this all works as a transaction. If this fails, then we shouldn't carry on sending things to the order, to the stock taking system. That should stop. But also, shouldn't we be sending an email and undoing this to say, sorry, there was a problem, your order is not going to be processed? Because this is the job, this filter here, that's the person who's in charge of sending that email to say that we're processing your order. And it needs to now roll itself back, if you like. Maybe that's what this compensating transaction pattern is all about. I'm not going to get into that yet. So issues and considerations. Consider the following points when you decide how to implement this pattern. Complexity, reliability, I can never say it. Don't do the same shit twice. You know, if anyone's not seen that, imagine you send an API call to add a note to say that your order's been processed, and for some reason there was a retry policy or a message retry policy, or using something like simple queuing system that can just give you the same message twice in rare occasions, then they're going to get two emails or they're going to get two notes. What you should do is you should make sure that that one transaction here only happens once. Each one of these items only happens once, and there's patterns for that. There's really good pieces of software that you can wrap a once around them, and it will only ever do that once. And because that will have a unique transaction ID, or should, that will be passed down, these things will only ever do the task once for that one thing, and only ever roll back that thing once. And any sequential duplicates, if you like, usually clicking the bloody button like that, then it won't happen. Repeated messages. If a filter in the pipe fails after it posts a message to the next stage of the pipe, another instance of the filter might be running. and it will post a copy of the same message to the pipeline. I think that's the same. This scenario could cause two instances of the same message to be passed to the next filter. To avoid this problem, the pipeline should detect and eliminate duplicates. Yeah, and it's not for free, this, by that. I've seen it a couple of times where there's great retry policies on HTTP requests, on message transfers, like service buses. And if anything fails, that instantly will try again 20 milliseconds, a minute, 2 minutes, 30 minutes, whatever, and it'll retry. Problem is that if that's like in like C# in some kind of try catch, it could actually have been successful, really. It could have got right down, you could have been writing to databases that might not have been transactional within that scope of that one unit of work. It might just save it. And therefore, a repeat message does actually duplicate things up. And if you don't think about that first, when you're building this thing and you go, right, let's build, like, imagine each one of these being a pod in Kubernetes, and it's a distributed system, and that's just sending to the other message via HTTP or event system or any kind of streaming mechanism. You got to think about that as you're building this platform. Context and state in a pipeline, each filter essentially runs in isolation and shouldn't make any assumptions about how it was invoked. Yeah, absolutely. Yeah. State and context, to the one and the same thing, in my opinion. It should be given its state, and that state should be reproducible. But that's where things can go a little bit wonky, is that state then, it means that pipeline or that filter can be different each time because the data is different. So you need to make sure that when you're unit testing these things, that you can think about all the different types of state data that it can be given. And that could be massive, 32 questions, you've now got over 4 billion combinations of unit tests. You got to think that through. Filters must be tolerant of data in the incoming message that they don't operate against. What? Filters must be tolerant of data in the incoming message that they don't operate against. They operate on the data pertained to them and ignore other data and pass it along unchanged, right? Yeah. Okay, I've seen this also. I've seen it where accidentally, this has got the customer's address, then the order, then the email ID, and then this goes in and processes payment and wraps the payment system and then sends that to the order system. The order system doesn't care about anything. It only cares about the shipping address and whether the payment was successful. And in some cases, they might not even care about that, because if there was a message that was sent to the ordering system, then why was it not already processed? So that interface only contains a small collection of data as its input. But then you've lost this data, you've thrown it away as you move into the system. Then some developer over here goes, I really need the surname. So what they do is then they write some code to go connect to the database down here to get the surname. And you don't notice, and it goes through PR and no one notices, and then it goes out into production, and then that pattern becomes ingrained. And each developer starts getting the the postcode from the database, and that one might get the email address from another database, and before you know it, you've really cocked up. So you must ignore the data, but you must not mess with the data. You should only mess with the data that's in your remit. That's complicated. How's service A supposed to know what data it is and isn't allowed to mess with, right? Error handling. Who does that? When to use this pattern? Use this pattern when the processing required by an application can easily be broken down into a set of independent steps. I'm gonna add to that. Within your code base, right now, guarantee it, you've got a great monolithic application or a distributed system, doesn't matter. Use some tools like like GitGraph and analyze over the last year how much of your code base has changed. And unless you're Netflix, which only Netflix are, I guarantee you, if you're just a normal sized software shop or you're building software inside of a company, I guarantee you it's the 80-20% rule. Only 20% of the code base, the methods, or the namespaces, or the modules, only 20% of that has changed in the last year. Prove me wrong. Go and have a look. Go and do it right now. Well, if that's the case, if you was to strip out that 20%, clean it up, break it up into the individual components, its unit of work, so the thing that it does, filters, write them independently, test them, make sure they work, and then one by one strip that code out of your system and call the new filter. You have now got stability, scalability, reliability, maintainability, all the abilities. You're a superhero now. The other 80% of your monolithic app is just sat there like it always has. You don't touch it. So now what you've done is you've radically improved how efficient you can be in your business with literally the smallest amount of work possible. And you can test this independently before you even put it in the system, because you can build one of these filters. You can test it on its own in isolation in a UAT environment. Then what you can do is you can get your main application, whether it's a monolith or a monolithic distributed system, whatever it might be, take your app and then just put an if statement around it as a feature flag, and then call the pipe instead. And after a week, once you're happy, or a month, whatever your business risk rates are, remove the if statement and just call the pipeline from now on in. And you're sorted, right? You're done. You've now took a bit of that complexity out of your big app. Imagine you've got a massive application written in, Angular 1 or Durandal, or, it was literally a bare bones system that you did. You can now start stripping bits of that out based off the analytics of what code changes the most, one by one. Each time you do it, you're adding significantly more value. Because when the business asks for a change, it's now a filter. Don't edit the filter, make a new one. Make sure it's correct, make sure it's valid to that state, release it, test it, now swap out. So this statement alone needs to be done with care. Yeah, you can break components out and make them independent, but you should think about what it is that you want to take out. Processing steps performed by an application have different scalability requirements. Yeah, You might have something that is a Lambda or, an Azure function that literally just spins up when it's needed. Then you might have another, which, is running in a 10 node Kubernetes cluster, on M3s or whatever they are, and just churning through data and pushing it out. You can't do that with a monolithic app. You got to scale the whole thing up or scale the whole thing out or up, and it doesn't work. It's a nightmare, because if it uses 10 gig of RAM to start up, then if you distribute across, you're still gonna be overutilized. You can't have 10 servers all with 10 gigs of RAM because they're all still full. So you've got no choice but to scale upwards. And that's where you get some big costs. That's where things start to get costly, in-house or on the cloud. So you require flexibility to allow the reordering of processing steps. Great one. Great mention. Great shout out. Really good for startups. I'm not too sure whether this is great for the general business, right? Because, you know, most companies don't come in and say, oh, we are now going to use Cheetah for our email server, make it so. Or, we're now going to use this for our ID&V system. That might happen once in a blue moon, and there'll be some real reasons for it, costings and stuff in order to make that shift. Businesses don't tend to change the processing steps dramatically. So I wouldn't do filters and pipes because it allows you to swap stuff around. However, that is super useful. In a startup, or where the company's doing lots of experiments and they're trying to improve efficiency and they're in their infancy, then hard coding all this stuff is a nightmare, because you try and second guess what you think the business is going to want, and it's never that, right? It is never what you saw in your mind. You're there programming away and your boss comes along and goes, Gary, can we just do this? It's like, where the hell did you come up with that from? And what you've built now actually hinders that new output, that new requirement. Where filters and pipes, if the business change radically, you build new filters and you reuse old and you swap them around and you have these Lego blocks. That's brilliant. The system can benefit from distributing the processes of steps across different servers. Yeah, it's just scalability, really. You need a reliable solution that minimizes the effects of failure in steps while data is being processed. Yep. Because, each one of these, you can have multiple copies of B all running in parallel, taking in lots of these because they might get lots of data throughput. So you can scale them out whenever you want. So the pattern might not be useful when the application follows a request response pattern. Yeah. So this is where, like it said, request response. If this needs data from this, then you're in trouble. That is really hard actually for developers to get around when they're trying this pattern, because most developers write a function that either mutates stuff that they're sending in as arguments, or the results of that function comes back and you've got a new object. So that's technically possible, but you really shouldn't. I think the arrows kind of dictate this. Arrows are going across to kind of show you how the data flows. Task B does not send data back to task A. If it needs that, then the feature or the method that's in task B really needs to also be in task A. And sometimes you only know that once you're in the middle of the sprint or the middle of the work. Let's stay agile. We're doing the work, the developer looks at it and they go, I need this data. And, pull the hand on code, get in a huddle, work it out, reassess, redo the plan, move forward. That data that was in task B is now in there. Or maybe task B just can't exist. It's got to always be in here. And now task A will now send data to task C, and task A is now just a little bit more complex. Sometimes that's it. That's the way it's got to be. Task processing must be completed as part of initial request, such as it's same thing. So the architecture should evaluate how pipes and filter patterns can be used and their workload designed to address the goals and principles covered in Azure well architectured framework pillars. Right. This is just a set of rules about how things should work and what you should focus on when you're building this stuff. But here's an example. You can use a sequence of messages, queues, to provide the infrastructure required to implement a pipe. The initial message queue received unprocessed messages that become the start of the pipe and filter pattern implementation. A component implemented as a filter task listens for a message on the queue, performs its work, and then posts a new transferred message to the next queue in the sequence. That's all right, but it means that needs to know that it's calling that, and that needs to know it calls that, and I don't like that. If we have a look at, say, something like AWS step functions. So AWS step functions allows you to, in a diagram, draw out what things are called. So, we're going to start off by validating the account data. That's going to be a filter. Then if the account filter is valid, then we can get some data and put it in Dynamo. We can send an email and we can say that your order's being processed, right? If it fails, then they can send it to this filter, which is going to send a failed email, and that results in a failed outcome. And of course, this is crazily simple. Some of these get massive, but the great thing about this is that none of these things know about each other at all. Where in some cases, the problem that you have with these filter pattern is that this filter then sends an email. And in order to do that, you've got to go into the code to change that logic. Within here, a product owner or a QA or a business analyst can make changes to this and say, right, do you know what? We're not going to send emails anymore. And when we do this part, we're going to do it further on down the chain. And let's see if that increases conversion or, if that produces less friction for the customer. And they can do that just by clicking on it and clicking, delete. And that's it now. Then this email's not going to go. But within most architecture, people design it and tightly couple the outcomes there. So what is this? Function. This looks like C# by the looks of it. So one of the things I like is there's a library called go-mediatr, which is like a clone, if you like, of the mediator pattern, which does a lot of this stuff. It allows you to take input and send it to another output system, but they're completely and utterly decoupled. So go get it, sends a request and gets a response, and then you have a dispatcher, gets a notification message and dispatches it. So you create a command, and this is your blueprint, template, interface, contract between all the different pipes. This is what the data is going to look like. Please don't mess with it. Only mess with the stuff that you in your permit, purview, remit, whatever. Then we've got a query request. We can query some data and we can get data. We can create a command to create a product and get a response back. So here we're going to just get an ID. And then we can get the product by ID response, and that's going to turn back with this product data. So one of the things here is you can kind of mess with this and get a pipe type system in place. One of the problems is that this is talking about sending a request and then getting data back, and that's not what this is. Remember, the pipe system is all about sending data that way. I don't even know where my camera's going, but hopefully that way. Where this does allow for responses, but just because it allows it doesn't mean you have to do it. Could do this just for sending data off. Let's have a look. Let's see if I've got an example that actually still works. Let's see if it runs. Yeah, so here we have in a hello world, we create a product and then we get a product ID back. So what have we got in this? How is this structured? So we're including the mediator, right? We've got a create product command. We create a product response and then a create product command handler. So we're setting up how data should look, how it should look within the system. So we can see the create product response, create product command handler. Awesome. Then a function which is going to handle data, and this is just going to handle the create product command handler, and this is going to print out and then return an object which is create product response, and that's just going to return the response. We could return nil and should return nil if we wanted to do pipes, and what should happen here is that this should then send the next message in the chain. What we're able to do is, the beauty of this is completely decoupled. It looks like a lot of code, but imagine if this was a huge system. What we're able to do is, using just these handlers, we are now able to say, let's create a product command handler, and then we register it. And when we send an event to create a product, we're going to get that create product response back, and we're done. This line here, this doesn't know how. It doesn't know how we're actually creating a product. It can be completely and utterly detached. So I don't know why that didn't do. So create product command, we've got that, we've registered it, And now when we do the create product command, it will then be passed to the command handler, which will then process it. This command handler now, using this context, will be able to actually use mediator to send another message. And now we've created this pipes and filter thing. So I might have a bit of a play with this, see if I can actually extend this a little bit to fit with that. But I'm going to do that out to show because we only got 4 minutes left. But we can see that, this would actually do it. Now, of course, this is all in one app, but it's still like one monolithic application. But this code within the handler can be chopped out and moved into a distributed system. So, it could be using something like RabbitMQ or Kafka or just an event store somewhere. And we can take this small isolated piece of code that runs on its own, that was in a module, move it out somewhere, and it will carry on working just as you'd expect. And everything was decoupled. I can create multiple copies of this to do different things. And all I need to do is in the handler, connect to a different handler. And that's it. We can completely swap out how create products works just by changing that handler. Let's have a look. So create mediator, register request. So yeah. Handler. That's then that is then obviously being used. Yeah, so I was hoping that it would be wired up in a better way, but at the moment, with Go, it's just the fact that this handler here, this is the thing that's actually registered, and therefore that's the thing that's going to get called when we run the send. So all I need to do is create a different version of this, and then I can probably change the outcome of it. Gosh, there's 2 now, so just need to change it. So let's deregister this. So now we're creating product v2. Obviously, there's better ways of doing it than that. That's to just demonstrate a point. I can swap that out. Now, if this now sends another message using the context, then I can kind of demonstrate how that would work. So here we're sending the context, which I think is just background at the moment, yeah. And then the command. So if I create a new command, come on, fingers, don't fail me now. So, I just typed all that out in seconds. Anyway, say hello and what I'm going to try and do is see if I can create a command handler for this. So say hello command handler. Going to see if I can return. No. In fact, because I'm returning nil, I'll just return if there's an error. Okay. So say hello command handler. We've got a message for the say hello command handler. At the moment, we have a command that we need to send in. Create product command. So we need a command for this. So I fell for that last time. I'm just going to type it out. Say hello command. Product. What I'm going to do is say that this is a message. It's a string. Yeah, that's right. Let's write it and see if I get any errors. No, I don't seem to be getting any errors from this. So I'm wondering now, when I create the product, whether I can actually do anything with it. If I get the command I should be able to do is get the message out of it. And now when I create a product, should be able to do is do mediator send. What am I going to send? Say command. And the response is just going to be what? Error. And we want to send it the context and the command, right? Well, the context is going to be the context that's passed in, so that it's long lived. It will keep on doing it. Not sure if I should create a new context off the back of this context. Chain it. But for now, let's do that. So I can cancel this. I could send a cancel event and it'll all cancel. Should be pretty good. Command. And of course, I don't have a command yet. So insert cmd equals what a just an address to say hello command. But we're going to do the message. I'm going to say be amazing. We're going to still then run this create product response and send that back. No errors. Well, no errors from Telescope at least. So we got hello world. We created a product too. I've put it in the wrong one, haven't I? I'm an idiot. Oop, that jumped out really quickly. So hello world, created product v2, product ID. So we didn't get an error. We sent the command. We weren't really bothered about the response at all. We didn't check if we got an error from it, which is naughty. But at the same time, when we sent the command, oh, we're not registered it. It's where there's a bit of goo, isn't there? So how do we register? We create the command handler and then we add it. So what do? We create a command handler. So say hello command handler. Equals a new create command handler. suppose say hello command handler. And then we register. Mediator, register, request handler. Seems to be able to work it out itself. Let's say hello command. Does that work? So say hello command handler of say hello command handler does not match inferred type. Mediator request handler say hello. Bit weird. Why is that? Say hello command. No, done it all over the place. Doesn't matter if you spell it wrong, as long as you spell it wrong consistently, eh? Could have just done a complete find replace numpty. What am I doing wrong? So line 57, say hello command of type say hello does not match inferred mediator of say hello command of type response. So there is a request to response. I wonder how it works that out. So what we've got here is we've got a, if you look at the other ones, there's a handler and that gets back a create product response and an error. That gets back a create product response and an error. But this bad boy just returns an error, which is fine. Well, that's what we're trying to do. Context and the command, they're just inputs, right? And that's part of the say hello command handler, which is fine in my opinion. But say hello command, create an instance of it. Then we register. But it's saying it doesn't match the match. So maybe this has to have a response. I'm not sure. So that's something to look into. When we send, I'm sending, and what am I passing in? Context and the command, yeah, as we'd expect. And then we're calling say hello command. We're going to pass in context and command. And that's the way it should be. So passing in context handler. Message, passing in context command of say hello command. I wonder if that's because we look down here. They have a message parameter, create product command. Oh, what are you doing? Mess with that. That one was all right. Say hello command handler. The channel. So it doesn't match inferred type. Now the inferred type, okay, of response for T request, T response. I wonder if it's because this is actually inferring the type. So T request of any. By I enforce that, and say that this is going to be of type, what is it? What we're passing in, say hello command. And handler. And we're going to get back an error. Yeah, nil is not a type. Can't just return that. Why is it not allowing me to return an error? You're making it uppercase, dickhead. So let's run that. Well, it's saying a can't. Still says there's a problem, even though I've inferred the types. I mean, this part here was the least of where I thought there would be a problem. So we have say hello command. We wanted say hello command handler. Is that true? So we're passing in a command handler, which is right. But when we go to implement this, it should be the say hello command handler. Still not understanding that. So we've got create product command, and it's saying we're passing a handler. Cannot use say hello command. The variable of the type say hello command handler. And that's what we were doing. We were registering a command handler. So for instance, create product command handler, we created that. Error. Value of argument to mediator register request handler. Say hello command handler error. Say hello command handler does not implement mediator request handler. Say hello error. Implement mediator request handler. So we have this handler, and that's apparently wrong because it's the say hello command instead of command handler, and we're expecting 2 errors back when we're only going to get 1 error back. So it's kind of wrong. I'm not quite sure how these bits glue together. This is the first time I've properly used it. So I think this spawns from this. Let's get rid of this helper. Where let it just infer its types. Really? Why? Say hello. Response for mediator. T request to response. So I think maybe it's struggling with the response type, which is a shame. Maybe it needs a better response type. Because register handler, it looked like it always needed 2 bits. The error and the response. So if we look at everything else, we've got 2 response types. A create response and an error. And maybe that's just the way that this is programmed. Which wouldn't work for named pipes, so sorry gang. I'll keep playing about with this, but I think that what's happening is that we must have a response type, or I'm just doing something really stupid, which is also, you know, on the cards. I'll just have another bit of play about with that, but I'll probably trim this video down because the you know the last 20 minutes. Hey, anyone watching, thank you, and I'll post down in the comments whether I got to fix this, maybe create a gist and post that out. Anyone that got to the end of this, you know, thank you very much. As always, you know, all I am, of course, the gizzard.